Okay, welcome back. This is a code example. It's not going to be cleaned up. I will do coding as we go along to show property-based testing. And I'll use the same example as we used in module 5 in the code example there. So this is a function called vecmin. This is the software under test that we want to test. And vecmin, the purpose with that, or the goal of this function, is to take in a vector of floating point values and to find the minimum value of that vector. The implementation is not perfect, but this is not how you would implement it because it's already available in most languages, of course, but this is just for the example. So a very simple function implemented in this way, and we're going to test it. But the new thing here is that, I renamed that, so let's read it in. We are going to test this function vecmin that we read in from its implementation file, this one, and we also include Julia's test package, so we get this way we can group test cases and we can run tests and so on. Okay, so the new thing here is we're going to do property-based testing, right? Before, in the code example, we used concrete automated testing. So we just wrote down test cases. Actually, I had some random testing in there. So then we are pretty close to a property-based testing. So to make this a bit clear and unique, I'll sort of develop a very simple property-based testing tool as we go along. So the idea in property-based testing, as you've seen from the lecture, is that we're going to write properties, and we are testing vecmin, so let's just name it property vecmin. And a very simple property is that if we take in one floating point value, we create a vector from that, we apply the sut to find the minimum. That minimum should be that value that we started from, right? So I don't know what to call the property, but length 1 for lack of a better term. We take in some number, and what are we going to do? We are going to put this number n into a vector. We are going to call our software under test vecmin on that. So vecmin on the array with a single number in it should then return that number, right? This is one property of this that we want to always be true. If we take in some number, we put that in a vector and apply the sut, we should get back the number. So let's execute that property so we have it in here. So now we could just call that, we could write a test which would be like, let's test that if we call the property with the value 1.0, it should be true. So what if we evaluate this? Now it's compiling the whole, something went wrong. No, it passed, right? So it's compiling the whole Julia package for testing there. So that's why it takes some time. And so the test passed, right? But this would just be a very convoluted way to run a single test case. So the whole idea with property-based testing is that we want to check this property for many different inputs. So we want to generate many different numbers, and we want to check this again and again. So what should our system look like? I guess we wanted to call something prop check. We want to have a system called prop check, where the first argument to this, so it's called quick check in the quick check system, but we are not doing a full quick check system today, so we just call it prop check. We give it a property, we give it a data generator, right? We need something to generate multiple datums, so we could give it an array of data, but it's more general to provide a generator here. So we need a way to specify a function that when called will give us data. So let's do make float 64 generator. This is a function that takes a max value, which is, I don't know, let's say we want to try up to 1,000. So this function make float generator will give back a function. So this is how we can write this so it's easier for you to see. We're gonna create a function that makes functions, and so inside this function we want to create a function called a data generator, and it has no arguments because it's going to be called by prop check many times. And this function is going to take a random number between 0 and 1, which is available in Julia if you call rand. So we can try that. We get a number there. So if we multiply this by max value that we got here, now we have a function and we return this function. So this is, you know, this looks a bit strange to you. Maybe it's a function inside a function, but you can do this in different ways. Of course, you can have in Java an object, which is the generator, but you know, to keep it lean and simple, let's do it this way. So we have something to make new generators, and these generators generates values between 0 and max value. So if we execute this, we can now test it, make float 64 generator. If we just call that with say 100, we should get back a generator, right? We get back a function. So that's just how Julia does that. And this function, when we call that, we get a value between 0 and 100, right? So now we can use this generator of data generators for floats, and we can try that, right? So we generate a generator. So we give prop check the property that we want to test and a function that will generate data that we use when we test this. So let's now write the prop check system, or function in this case, because it's super simple. So we have the property, which is a function in Julia, and we have a generator, which is a function in Julia, right? So it takes two. Probably we want to say how many times are you going to check this property, right? So what do? We loop in 1 to n, and every time we generate a new data by calling the generator, and then we check prop is true is where we check. So we take property, we give it the data, and we check if this is true. This is, you know, this is not how you would write it, but let's just make it clear to you what's happening. So we generate a new data, call the property with this data, check that the return is true, and save this Boolean value in this property here. And if now prop is true, then we say test true, because we've already done it, so we can do it like this. Or if it was false, we do test false. So these two tests here are just to ensure that we count the number of times. But if it's false, we actually want to break, otherwise it will find multiple problems like this. So, you know, here maybe we want to provide some, I don't know, I mean, we could do this in nicer ways, but let's just say that let's do something dumb here just to get an indication. Property is false for data. So we just generate a string here. so that we know. And this string should equal something et, which is so this will always be false, and then we will break, right? So we will get this information here, hopefully, if I'm thinking this through. So we now have a property check. So this is our property-based testing tool, actually. This function here, it takes in a property that we give it, a generator which we give it, and the number of times, and that number of times we are going to check that the property is true. So let's compile prop check, and should we now be able to run it? We've tested all elements, so let's run it. It will compile a lot of stuff. That was fine. We don't get any reporting, so we want to run the whole test set, and then it will count the tests that pass. Let's see what we get. We should get a report, or what did I forget? Oh, we got it. It's just compiling stuff. So we'll go faster next time. So it actually runs 100 times. So let's check that. If we now give it 1,000 times and run the test suite, we get 1,000 passes, right? Okay, so we now have a pretty powerful system. We can go up here to 10,000. It's still, of course, very fast. We can go up to 100K. We can go up to 1,000,000 just to be fancy, and that takes a little bit longer, right? It's still fast. So we run 1,000,000 tests of this property here, right? It was just a single property, and of course, you know, you want to take this down. Let's go with the default, but so what are the problems here, right? I mean, we are only testing floats in this range, so this is maybe something we want to change, and we want to go up to, I don't know, 1,000,000 there. Why not? And it's still fine. So let's go crazy and do 50, 10 to 50. Why is that taking longer? Oh, it's compiling now the failure information. So I didn't get a lot of... okay, so it's compiling stuff. This is the interface compiling up things to send things back and forth. So it's not typical of the times you would see. So you get one failure here. If we hadn't had this logic here, we would have gotten probably many more faults. So this was a little bit convoluted maybe for you to understand, but it was simple here. And we say, so do we get some kind of, yeah, so property is false for data. Okay, so this is a pretty large number here. So vecmin doesn't seem to work for this number. Okay, we can just test this then. What did we have? We had the original property was to put that in there. So let's see, what do we get back? Okay, so it finds this thing here, which is, you know, in our crappy little implementation of vecmin here, we can see the reason for this, because quite arbitrarily we had a limit here, which was exactly what is, so this is not how you should implement vecmin, of course, right? So this was a very simple, and in practice, of course, you would write much more complex properties like this. What else do we want to show? Maybe when we want to do something else, we want to do, I don't know, the reverse. Maybe we want to do minimization. That would be nice. So now you saw a problem here is that for a complex soot that you're testing, you wouldn't be able to find where the problem as easily here. So you would like to know what's kind of the minimal value that will show the problem here, right? So when something goes wrong, you want to call a minimizer on the value, to find a better example of when it fails, right? So what we want to do is in prop check to extend it so that when the property is false, we want to call a data minimizer which needs access to the property because it's going to ensure that the property is still false, and it's going to start from the data D which led to the property being false, right? So before we report here, we want to minimize D, right? So we're going to give in the D we have, and let's say minimal D. And this will not be minimal in a formal sense, but at least we want to get closer to something, right? Minimal D. And we're going to report minimal D. Let's put it in there. And we're going to say starting from D, right? So we're going to report them both just to be fancy to show you here. So we want to right now, we want to extend our property-based testing system with a data minimizer. It will take the property and will take D, and it's going to try to find a smaller example. So how would you do it? Yeah, I mean, this is type dependent, so you need many data minimizers. D, and here we're only gonna do a minimizer for when the type is a float, right? So we're not gonna do data minimizer for all different types, but this is going to work for float. So we are going to try num tries is 1,000 times. We're gonna try to minimize D. And what does minimize mean? It means probably finding a smaller value for floats. So what are we going to do? For T in number of tries, we're going to try to update D while keeping the property false. So we're going to do something to D. So let's say we have two ideas. Either we divide by 2, or yeah, that's probably the easiest. Either we divide by 2, or we take a random value between the actual value that we have. That's actually similar, but okay, let's not be too fancy. If a random number between 0 and 1 is less than 0.5, which means half of the time, so 50% of the time, we're going to try generating a new D by taking D and dividing by 2 plus rand. So we take a value between 2 and 3, because this can be maximum 1, so this can be 3, and we divide by this. And if rand was not less than 50%, so in the other case, we are going to do, I don't know, what are we going to do? We are going to take D minus, I don't know, a random number between 0 and 1000. So, you know, of course, these are just two examples of minimization operations, right? When we have this new D, we're gonna check if property new D is equals to false. We're gonna update D to be new D. Otherwise, we keep it and we try again. And then in the end, we are going to return new D. Okay? So you with me? So I think that's it. Hopefully I thought about everything. So we compile them both. So we have now our data minimizer, and we are calling the data minimizer with the property on the existing data for that. So yes, and we return the minimal d, and then that's what we report them both. I think we compile them. So if we run the first property check on up to 100, we didn't find any problems, so we should still get 100 there. And then when we run this, something interesting should happen. So it started from, so now of course it didn't get the same number as before, so it found the property to be erroneous for this large number, 10 to 49, and then it was able to reduce it to this number. That doesn't look correct, right? Can we check the property for this? What did we have? Property vecmin length 1. So it should be true. So something is wrong with my data minimizer. If property is okay, so we start from right, so we want to return, I don't know why I did that strange thing there. Right, so we start from D and we return D because D is what we update. So let's recompile. This one we already compiled. So the first one should still pass, no problem. The second one should now, yeah, okay. So you see, it started from 5.8 something to 10 to 48, and then it couldn't minimize more when it came close to this limit. Of course, it still doesn't look so nice, so I'd like to change my data minimizer to take away to round. In the end, I want to round. So let's try. Let's save a few tries here. So we save 10 tries, and in the end we are going to try 10 times to round the value. D and the number of digits. The number of digits we round with is going to be a random integer between 1 and 8. So if the property still is false, I don't know, this is not the best way to do it, but you know, we round the number and we check if this new number is still false, and then we go on. So you don't need a loop here. I'm not sure what I'm doing, but anyway, we just need some kind of rounding to be tried. Okay, yeah, that's what we do. We should try all of the roundings and see which one is better. Right, I don't want to spend time on this, so let's go with this very bad implementation for now. We have a better data minimizer. We don't need to recompile that, but anyway, the first case is still true. The second case is okay. The rounding doesn't work. Okay, why is that? So the logic is skewed somehow. What am I doing here? round, take this, I should have maybe that. What's going on? Ah, okay, it's because it's a large number. Okay, I see. Ah, okay. So we need a smarter way to round. We want to take away some of the. Okay, I see. Okay, so you need a smarter way to round. Because this is actually not 1.8, it's 1.8 something times 10 to the 10. Okay, so you see the problem, right? What you would do is just, you would rather divide and then, so we take some number of times. So divisor is 10 to a random number, which is between 1 and I don't know, 5, right? And then you do round. Yes, you do round to an integer after you divide d by the divisor. Yeah, I mean, I'm not thinking clearly here now, but I just want something that shows you a nicer way to minimize. So round to integer, so the new d is going to be a float in the end, where we first round it to an integer, and then we take and we multiply it again, divisor, after we've made an integer of it, and then we get back a float. So this will take off some of the end digits, hopefully. Okay, so we don't need to recompile. The first property still is fine, the second one. Okay, so at least it took away some of them, and I can refine that. But okay, you see the point, right? The idea of property-based testing is we are going to write properties, and they are super simple expressions of oracles. And I don't go into what other properties could we have for Wekmin. To do property-based testing, we need something to generate data. And then it's very simple to do a small property-based testing system. It could be as easy as this. And then we added a data minimizer just to make it a little bit easier for us as humans to see. And as you can see, I could easily have done this much smarter, but I didn't think that through before I started the video. So that's what you get. So if we now run the whole thing, it fails there, right? And of course, at this point, we would go and check, and we would say, oh, this is a very crappy implementation of this. So actually, we should start from infinity here, right? So if the value is less than where we started, we will save it. And if we start from infinity, actually, that might be a better implementation, right? So then we can check, and then we get 200 times. And since this generator is much more general, we can now go and run for 1,000,000 times on this one to get a little bit more confidence in what we're doing. And then you get 1,100,000 tests passed for a much more general. Of course, there are many limitations. We are not generating negative values and whatnot, so this is still, you know, not a very good property-based testing system, but you can see how easily it can be done in any programming language where you have basic unit testing framework in there. So thanks a lot for this video. Hope it helps you with assignment 3 and understanding property-based testing. Thanks.